All right, let's dive right in. Today, we're going to pry open that black box of machine learning and look at the one thing that makes it all tick: data. And not just any data, we're talking about structured data.
Okay, let me ask you a question, and it's a simple one. Have you ever used a spreadsheet? Like Excel or Google Sheets.
If you said yes, then I've got some great news for you. You are way more ready for machine learning than you probably think. Seriously, because that simple grid of rows and columns you've been using for years, that's basically the blueprint for a huge chunk of ML.
So, here's what we're going to do. We're going to take everything you already know about spreadsheets and just translate it. We're going to learn the official lingo, the vocabulary that data scientists use. But trust me, you already know the concepts.
Okay, first word on our list: feature. What is it? Well, a feature is really just an input variable. It's a piece of information, an attribute, a characteristic. It's something you use to make a prediction.
So let's make this super concrete with a simple gradebook. When we say features, what are we talking about? It's literally just the columns. Things like attendance or homework 1. These are the pieces of the puzzle we're going to use to try and predict something else.
All right, so if you have all those input columns, those features, what are we predicting? That brings us to our next term, the label. Now, you can have tons of features, right? But you usually only have one label. The label is the one thing you're trying to predict. It's the target, the answer you're looking for. So looking back at our gradebook, it's pretty obvious, right? The final grade column, that's our label. We're using all the other stuff, the features, to try and predict this one single thing.
Okay, last one of the big three. We've got our columns, the features, and the label. What about the rows? That's called an instance. An instance is just a single data point, one complete observation, one example.
So yep, you guessed it. An instance is just a row. So see John Smith's row here? His name, his attendance, his homework, that whole line is one single instance. And here's a little bonus technical term for you. In machine learning, all those feature numbers in a single row often get bundled together into something called a feature vector. That's the package of numbers the computer actually crunches. All right, there you have it: features, labels, and instances. That's the core vocabulary. But this isn't just theory. This exact structure is hiding in plain sight, powering things you probably use every single day. Let's look at some real-world examples. Think about sports, like professional basketball. Each player, LeBron James, Steph Curry, they're each an instance, a row in the data set. And all their stats, points per game, rebounds, assists, you name it, those are all features. So what's the label? What are we trying to predict? Well, maybe it's something like, will this player win MVP this year? Yes or no? Or how about your music streaming app? Same deal. Every single song is an instance. And all those weird musical attributes they measure, like danceability, loudness, acousticness, those are the features. And the label? That's the big question. Will you like this song? It's a simple yes or no prediction. See, it's the same pattern over and over. So we've spent all this time talking about these neat, organized tables. But one of the best ways to really understand a concept is to look at what it's not. So let's talk about structured data's wild, chaotic sibling: unstructured data. Okay, so on one side, you've got structured data. It loves living in neat tables and databases. Think spreadsheets, bank records, customer lists. Everything has its place. It's easy for a computer to read. But then you have unstructured data. This stuff has no predefined format. It's the Wild West. We're talking about the text in your emails, your photos, audio files, YouTube videos. It's just a blob of information. And for a computer, that's way, way harder to make sense of. And get this is the crazy part. Most of the data out there in the world, something like 80 to 90% of it, is unstructured. That's a huge amount. It's actually the main reason that this whole other branch of AI, deep learning, had to be invented, specifically to tackle the massive, massive challenge of understanding all this messy human stuff. So you might be thinking, wait, if most data is unstructured, why are we focusing on this tiny little slice of structured data? Great question, and the answer is simple. Because this is where it all starts. Understanding this clean, organized architecture, it's the foundation. It's the bedrock of how we teach machines to predict things. This whole row and column setup is the heart of what we call classical machine learning. You've got these incredibly powerful, reliable algorithms, things like linear regression, decision trees, that are the workhorses of the industry. And they were all designed from the ground up to run on exactly this kind of organized, structured data. And this is where the real magic happens.
The reason the structure is so powerful is that it lets a machine learn systematically. It can look at thousands or even millions of rows of instances and start to find mathematical patterns. It can test out, when this feature goes up, what happens to the label? It's literally discovering the hidden rules in the data, and that's how it turns those patterns into powerful predictions.
So let's wrap up with this idea. Now that you know the language, features, labels, instances, I bet you're going to start seeing this structure everywhere you look. And it makes you wonder, right? If we can use this simple framework to map something like study time to final grades, what other amazing, world-changing relationships are just sitting there, hiding in a spreadsheet, waiting for someone to find them?